All right, boys and girls. Now, here is an important lesson. I want you to pay close attention to what we're doing here. We're asked to write a function rule from a table. I'll show you one first way that is kind of intuitive, but I would prefer you learn the second way. That is best, and that will be much more applicable for your future in this math course and future math courses. So, we're dealing with mainly linear functions. So we can just look for a pattern. And if we notice here that every time, oops, those are in the wrong spot, but if I add 4 to the x's, that'll give me the y. So every input plus 4 gives me the outputs. Therefore, I could write a function rule of f of x is inputs plus 4 gives me the output. All right, so I noticed that one there, but a more universal way, or especially if they don't give me a nice little 1, 2, 3, 4 for my inputs there, would be this way I'm going to do now. So first, you got to identify the common change, and you got to identify your starting number, or the zero number. What would you have if your input was 0? So in this case, the common change, or in every case, the common change is the change in the output compared to the change in the input. And when I say compare, we use a fraction line to compare in mathematics. So in this case, if I change the input by 1, the output increases by 1. So there's a 1 over 1 change. The beauty of this is I can pick any two pairs, or any two pairs of coordinates. So if I go from change by 2 on the input there, then I'm going to change by a positive 2 on the output there, and that 2 over 2 gives me that same 1, which you may recognize as slope from a previous class. Now, for the 0 number, just continue the pattern backwards. What would I have if I plugged in x of 0? I think you can see that that would be a 4. That's my starting number. So that's going to give me my function rule. It's going to be the output over the input times x plus the starting number, which in this case gives us this. For the next one, my input is my x's, and that's going to be the pounds of nails. It makes more sense to input how many pounds of nails I buy to determine the cost. The cost depends on pounds of nails that you buy. So, reusing that rule, the change in output over the change in input, well, for every 1 pound of nail, it's $1.19. Now, if I plug in a 0, I'm going to pay $0 for it. So that is my starting number. That gives us this for a function, simplified. Now, if we're going to plug in a 12, this is how that looks. F parentheses 12 just means I'm plugging 12 into this function. So this tells me what to do, and this tells me how to do it over here. And then I do that, I get $14.28. So, I know there's a couple longer videos, they're a little wordy, but here's our last example. Now, this one didn't really fit the mold quite the same way, but it's relatively intuitive. Our input is going to be the number of chirps, because it says that we can figure out the temperature based on the number of chirps. Right? And changing the number of chirps is not going to change the temperature necessarily. All right, so temperature is our y, so is equal sign, so y is, should have written a y there. And 40 more than, so that means we're going to add 40 to something. And what are we adding to? 1/4 the number of chirps. So the number of chirps is our x variable. It's 1/4 times that. There is our formula. All right, so there's a few, and we'll do a lot more practice so you guys can master this in class.